At the same time, the vehicle which is traveling in 80 kmph has to be come into a stop position in a very controlled manner, which is taken care by the high a good efficient braking system in a vehicle. These are the values which are in general, but it depends upon, it varies according to the vehicle. So these stopping distance and stopping time are the key factors which will be evaluated while testing a brake system. Then comes the mean fully developed deceleration. It's nothing. It is similar to a deceleration where we'll be taking the 80 to 10 percentage of a stopping distance value, and we'll be calculating the deceleration in meter per second square. So here I'll just quickly explain the formula. The V1 is the initial start speed of the vehicle. Start speed, I'm saying the speed at which the brakes are applied. Next, VB is the vehicle speed at zero point 0.8 V1. 0.8 V1 is the 80 percentage of the initial speed. That is the starting speed of the vehicle. Then the VE is the 10 percentage of the starting speed of the vehicle. SB is the distance which is traveled between the 80 percentage to for the starting speed of the vehicle to the 80 percentage of the starting speed. Then as the SC, which is the distance traveled between the starting speed to the 10 percentage of the starting speed of the vehicle. Starting speed is nothing but the speed at which the brakes are applied. This is the very basic theoretical calculation which will be used to cross verify the data which are evaluated from the tag systems which is used for the testing. Then comes the coefficient of friction and adhesion utilization. This is also a very key important factor which will be taken care during the testing.
We explain TypeMaster from engineering to customer, the leading solution for homologation management in vehicle construction. What is homologation? This is Tom. Tom has just fulfilled his dream of a new car and is taking his first ride. But it was a long process before Tom's car could be produced. An important part of that process was homologation. But wait, what does homologation actually mean? All vehicle manufacturers who want to launch a new vehicle on the market must comply with certain rules and regulations. This is not only the case in Germany, but in most countries around the world. To ensure that everyone sticks to the rules, each country has its own monitoring authority. Only when everything is in order, approval is granted, so nothing stands in the way of vehicle production. In the EU, these rules are standardized. This means that Tom's car is approved for use on the roads in Italy, Spain, France, and all the other EU countries. But why all these laws and directives? The laws ensure that every vehicle manufacturer in the EU has the same rules when it comes to the approval of its model ranges. In technical language, this is referred to as type approval, type testing, or homologation. This is extremely important. It ensures that everyone complies with the exhaust regulations to protect our environment, the safety of the vehicle in traffic, or the noise level within specified values. Thanks to homologation, Tom's car is perfectly suited for the road. With this in mind, Tom enjoys the ride in his new car even more. TypeMaster, the leading solution for homologation management.
I hope the video would have given a brief idea about what is homologation in vehicle certification. Depending upon the country, the testing procedures, standards, and the norms. Generally, homologation is a process of testing, validating, and authorizing any motor vehicle. It can be a car, truck, trailer, motorcycle, bus, the systems and components which has to be certified according to the official standards of the country. Uh, these standards generally aim at improving safety, environment protection, and product quality and production process. Generally, an automobile before commercial sales and marketing have to be homologated and approved by the testing authority for the use on public roads. The generally homologation authority can be the Ministry of Road Transport and Industry. It varies depending upon the country. Homologation has two types, which is vehicle type approval or the vehicle certification test. It is general classification. One more classification is the component type approval. Generally, individual components like valves or the ABS components. But I'm just talking about only about the brake systems, component type approval, and the whole vehicle's level approval will also be certified. These tests are being carried out according to the Central Motor Vehicle Rules in India, which defines the process for homologation. Generally, the major system which are being homologated is the active safety, which comes the steering system and the brake system. Then comes the passive safety, which will be the airbag, the passenger protection systems, seat belts. The component level will be we can take it into horn, mirror, glass, wipers, tires, and tanks. Then coming the environment protection system like fuel consumption, air pollutants, noise emission. Generally, this comes with the pollution related systems. These are the major systems which will be. Next, coming to the homologation and brake testing. I'll just quickly run through standards and the each states. Generally, according to CMVR, in India, highest
Sorry
double
for the interruption, Vignesh. Can you increase your voice?
for brake testing, the homologation is in India. It is under the standard IS 11852 for brakes and brake system testing. Generally, this standard has totally nine parts which are being explained in this IS. So, in this total nine parts, the major I have just accumulated all the major tests which has to be carried out in a vehicle to be certified for brakes and brake systems, which will be coming under part four, and which will for part four for the static test, and part three and part nine for the dynamic test, which will be seen in the next slide. So coming under part four, there are five important tests for any vehicle. I need to say this part four is applicable only to vehicles which are equipped with the compressed air or the pneumatic air or the air assisted braking system. So at the same time, this IS 11852 will not be applicable for vehicles like two wheelers, three wheelers, and the vehicles which are uh, vehicles with design speed not exceeding 25 kmph, construction equipment vehicles at moving machinery. This will not be coming under this regulation for your information. So, then moving back to the static test. First is the capacity of the energy sources test. Here, the energy source is compressor. We will be validating the time taken for the time taken by the compressor to fill all the reservoirs in a particular time. We are having standard values which are mentioned in the IS 11852. The vehicle, the compressor has to fill all the reservoirs which is provided in that vehicle brake system in that particular time to meet the requirement. So this is the capacity of energy source test. Then coming to the energy reservoirs, we'll be having, as I said before, we'll be having minimum three to maximum six to seven reservoirs in a tank, depending upon the capacity of the braking requirements. They will be designed and increases for multi-axle vehicles. In this test, we'll be generally static brakes for nine applications. where will be the vehicle will be in a vehicle will be in a all healthy condition where the cutout pressure is reached and the vehicle will be turned off, and eight static applications will be applied, and in the ninth static application the air pressure in the reservoir should not be less than the one half of the overall system pressure. For example, if the system pressure is 8 bar, that is the cutout pressure of the vehicle is 8 bar, and the energy reservoirs after 8 brake should be having plus greater than or equal to 4 bar to meet this requirement. Next, coming to the spring brake test. Here also the same procedure will be followed. All the reservoirs will be fully filled, and at the cutout pressure, three parking brake application will be applied, and the remaining pressure in the spring brake actuators are either if the vehicle is equipped with a separate reservoir for the parking brakes, the pressure in the reservoir or the spring brake actuator has to be noted down for the this test. Then comes the reaction time measurement, which is nothing but the response time of a vehicle. This plays a very important role when coming to the efficiency part of a braking system. Generally, the efficiency of a brake system is valued or defined based upon the response time of a response time of a brake system. How quickly the brakes is responsive with comparison with in addition to the driver's response time. We'll just remove the driver's response time and how the brakes are responsive to this application of the driver. So this will be will be evaluated in the reaction time measurement. For a 0.2 second of pedal actuation, the overall response time in a vehicle for the vehicle should be less than 0.6 second. It means uh, the, the overall time which is taken by the air pressure to reach the brake chambers in for the applying the brakes should be less than zero point 0.6 second. This is as per regulation mentioned in ISW 852. Then coming to the control line failure test, this is very rare and it is not applicable to all vehicles. Only to the tractors. I mean, tractors is the prime movers, which is coupled to the trailers to pull the trailer vehicles. Next, coming to the dynamic test, these tests will be carried out on the test tracks or the proving grounds. First is the performance test. ED and EC denotes the engine disconnected and engine connected stage. Performance test value defines how good a braking system is. This is a very basic test of any vehicle equipped with a air brake system or either hydraulic brake system. It depends upon the vehicle energy source. So this is the very basic test which determines the overall performance of a good healthy brake for evaluating the or defining how good a brake is in this vehicle. So in this test have separate standards based upon the starting speed, how much is the stopping distance, how much the deceleration should be. This depends upon the values, which is explained very detailed in the ISW 852. Then next, the secondary performance test. Here, what we'll be doing is that we'll be deliberately failing each circuit in a vehicle. For example, front circuit will be failed and the rear braking system, rear brakes alone will be tested. And the vice versa, the rear brakes will be failed and the front circuit will be tested, and it should be and the vehicle should be stopped based upon the within the stopping distance and the deceleration which is given in the ISW 852. Then next is the dynamic parking test. This is a test where the vehicle will be moved on a particular speed and the parking brake will be applied. So in the two cases where even the primary circuit and the rear circuit fails, with the with the parking brake, the vehicle has to stop within an admissible stopping distance and very decent deceleration. This is the main ideology of doing this test. So next comes to the fade test. Fade test is the nothing is directly means the how good the performance of the liners are there based upon the repeated application of the brakes or the continuous application of the brake. So next is comes the hot performance test of the exhaust brake test. Generally, most of the heavy commercial vehicles will be equipped with exhaust brakes. Now, as per the standard, the exhaust brake has to give a deceleration of zero point 0.5 meter per second square or more value to evaluate this test, or either the hot performance test has to be done to meet the requirement. Then comes the gradient test. Is nothing. For a vehicle, for any vehicle, the gradient test has to be carried out in both uphill and downhill gradient. For any vehicle, it has to be the parking brake has to hold the vehicle stationary without any movement at 12% gradient. Sorry, 18% gradient. It is nothing but the 10.2 degree both uphills and downhill. So this will be evaluated based upon the uh, performance in the of the parking brake. Then next comes the ABS performance test, where the vehicle equipped with the ABS system will be tested on different friction surface, that is high friction surface of zero point 0.8 mu, low friction surface of zero point 0.3 mu, and different vehicle tests are carried out in low friction surface in different speeds and different split mu is certified for the brake system according to ISWM 552 will fall under these six categories. The M1, M2, M3 represents the vehicle which is allowed to carry passengers. M1 will usually be the cars. M2 will be usually the tempo travelers. M3 will be the buses or school buses or the bigger buses. Then N1, N2, N3 will are designed to carry goods, cargoes in a vehicle. It depends upon the tonnage it is categorized. And according to our braking system, N3 will be mostly fitted, will be having pneumatic brake system, and N2 will probably can have both the pneumatic and the air brakes. Then comes the N1 category, which will be usually the small vehicles, which can be, we can say the Tata is and Ashok Leyland those vehicles, which are designed to carry less than 3.5 ton loads. Vegetable carrier, something like that we can take. So any vehicle, depending upon the tonnage, is categorized and certified according to the category, and the brake system will be equipped based upon the vehicle weight and the vehicle speed. These are mainly the vehicle brake system are designed based upon the vehicle weight, and the certification is also carried out based on the vehicle weight. So this is the major thing which will be of this webinar. Then next comes the process flow, which is this is the basic flow of which is followed for brake testing in a company or a testing authority or anything. Quickly, just run through all the process line, lined, lined up. First, the test requirement from the customer. It can be anyone, which who either you will be test customers can be anyone, either he can be a OEM or a tire on supplier. Whoever manufactures the vehicle, he will be the customer who want to homologate his brake system, he can be the customer. Then comes the test activity planning and slot allocation. The test, the dates will be prior and prior will be sent to the customers for activity and for testing activity. Once the vehicle is received at the test track, the documents will be verified and the test engineer will be assigned. Once the test engineer will be assigned, he will be the sole responsibility for the entire vehicle testing, entire brake testing from vehicle washing to the complete homologation and vehicle certification. So after the test engineer is assigned, the first main thing is the vehicle has to be completely washed. There should not be dust accumulation or or any oil leakage from anything. Just to be thoroughly washed and it has to be dried for 3 to 4 hours. After that, ours is a brake testing. It will be first thing we have to do in a brake circuit and the component brake verification. This has to be done based upon the original brake circuit, which is given by the customer. Customer, he can be a OEM. We have to very keenly uh, verify the brake circuits which is given in the vehicle and the document or seen. So after this procedure, we have to continue with the static test. Static test is the part 4 test which I have explained in the starting, which has to be completely tested. Then is the EOL test. Any vehicle equipped with the ABS has to be thoroughly tested for the correct functioning of the valves and the sensors which are fitted in the ABS. This can also be this can also be done for conventional air braking system also, where I told safety checks and the other important key parameters like tire pressure, load distribution, everything has to be taken care the COL test. That is the vehicle is completely ready for carrying out the dynamic test. Then we can couple the COL test and vehicle preparation and instrumentation, where vehicle preparation is will be coming under this part of tire pressure, load distribution, and or other safety equipments which has to be present in the vehicle. After that, we have to take the vehicle for part 3 dynamic baseline performance test, which I told the six tests which are given in the part 3 dynamic has to be evaluated. Then we have to move on to the part 9 ABS performance test. ABS performance test, as I said, the worst performance of the ABS are being tested in different friction surface to evaluate how good an ABS at the worst scenarios in the different friction surface under different speeds. Then the vehicle is normalized and everything, all the data acquisition system, everything is removed, and the vehicle is kept to normal, and, and everything, once everything is completed, it will be communicated to the customer for himself to plan for the homologation with the testing authority. Then the test report as per the standard has to be prepared and shared with the customer for future reference. Then he can plan for the homologation with the testing authority for certifying his brake system as per the regulation. So next, we'll just quickly rush up through this skill set for a vehicle test engineer. For any vehicle test engineer, the basic knowledge of automobiles, components, and functions of different systems has to be definitely he has to definitely equip with the for the basic of the automobiles. Then the basics of vehicle dynamics, how a vehicle behavior will be in different speeds and during evasive maneuvers, how the vehicle dynamic behavior changes. This has to be at least not practically. You may not felt this, but theoretical assumption has to be definitely there for all of you. Then excellent driving skills. This is most preferred, where you can, if you have a good driving skills, you can slowly test the vehicle and feel how the vehicle behavior is in different friction surface, and according how the different systems are functioning in worst cases, like in very low friction surface and thing. Then comes the basic vehicle electronics and electrical system knowledge. This normal how this is very mandatory for everyone. Then test case development, application and functional level testing. This is also one of the key factor. This and all you can develop after getting into the job. Then obviously the interpersonal skills is very key thing, since we'll be communicating with customers testing authorities. We should have sufficient communication and interpersonal skills to uh, convince and technically satisfy all the people. Then analytical and problem solving skills. This is also a very important skill. Then comes the future scope for a vehicle test engineer. Generally, vehicle test engineer jobs are not as abundant as IT engineer, but they do have very good opportunities in India and abroad also. Here, when coming to India, the main testing authorities or the major testing authorities who certifies and homologates the different systems in a vehicle are the RI, VRDE, ICAT, CRC, TUV, CRT. They all take care of the homologation and certification of different components and vehicle level approval. They are all government sectors where you can peep in as a vehicle test engineer. You have good scope. Then comes to the OEM, original equipment manufacturers like Ashok Leyland, Tata, Mahindra Trucks and Bus Division, Daimler India Commercial Vehicles, Volvo Asia Commercial Vehicles. These are the major commercial vehicle OEMs in India where you can drop in your resume or for jobs if on checking on their websites. Then the tier one suppliers are Nord Remse, Vaco, Bosch, Continental, Breaks India do have openings for a vehicle test engineer. Then comes the foundation brake manufacturer. Foundation brake is done with the drum liner manufacturer, slack adjusters manufacturer. They, they, they do have a sufficient opening for a vehicle test engineer. So how the career progression will be for a test engineer? You just enter as a junior engineer. You can be a trainee as a graduate engineer trainee or a postgraduate engineer trainee, or you can directly enter as a junior engineer, where you will learn how testing is done. Everything you'll come to know how what is vehicle testing, and just have a brief knowledge of and the basics of how the testing is done. Then vehicle test system tester. Then comes the senior tester. Then system lead, where you will be solely responsible for individual systems and the testing and everything. Then comes the specialist. You will be the specialist or expert in the complete system. For example, ABS or ESP or ADAS uh, or autonomous braking system. You'll be the specialist. Then comes the team lead or engineering lead for complete vehicle testing and validation. These can be divided into two things. One is the homologation certification, vehicle testing and development, where you will be put into will be the complete lead for entire testing activities and validation. So then we come to the end of the webinar. Let us open up for a Q&A session.